start of Chapter 8. Chapter 8, dealing with graphing. Whoops, sorry. Don't have my video. I have my video up. I don't have my screen. So you saw it. I didn't see it up here. Chapter 8 deals with variables, two variables, graphing. We're going to start the process of equations with two variables. Points, lines, introduction to functions is the real definition of it. So let's start. Equations in two variables. There's some vocabulary. Ordered pair. Those are called coordinates. Whoa, an ordered pair. Coordinates are x and y. They can be other ones. They can be a and b, depending on what the axes are labeled. This is the x-axis typically. This is the y-axis. But you can have different things that you're measuring or comparing, or the relationship between the two things. So you can have a whole sort of things. Typically, the horizontal axis is the x-axis. The vertical axis is the y-axis. Solution to an equation in two variables. That's an ordered pair. So we see x comma y. You see 3 comma 4. The x value would be 3. The y value would be 4. And it's a solution to the equation. To solve an equation, find the set of all solutions. Sometimes there's going to be 1 point. Sometimes there's going to be an infinite number of points. Oh, look, the ordered pair. Ha! Yeah, so they showed that it can come in different ways. X, Y is not the same as Y, X. The order is important, absolutely. Ordered pairs are always going to be alphabetical. Typically, they're alphabetical, 99.9%. And then caution number 2, equation 2x plus 1 equals 5 is a one variable equation and has one number, 2, for its solution. 2 is the only value that goes in for x to make this left side equal to the right, which would be considered a solution. The equation 2x plus y equals 6 has two variables and will have lots of different solutions to this. The numbers of the solution pair of an equation in two variables are written in the alphabetical order of the variables. So again, we would write it x comma y. We look at a problem, We'll deal with that later on. So state whether each ordered pair of numbers is a solution. So notice if we plug in 1, we have the coordinate 1, 4. That means x is going to have a value of 1. Y is going to have a value of 4. And we're going to plug that in to the equation 2x plus y equals 6. So we'll plug in 1 for x, 4 for y. And we're going to simplify the left side. And when we simplify both sides, is it come out to make a true statement? If it is, if it's a true statement, then it is a solution. If it came out false, like 5 equals 6, a false statement, then that coordinate, that point, that solution, that ordered pair would not be a solution. So 1, 4 is a solution. So why is this not a solution? Because when we plugged it in, we get 4 minus 2 equals 6, and we would have gotten 2 equals 6, which is a false statement. That's false. So we know that this ordered pair is not a solution. Okay, so that's what we're going to be doing. We're going to be testing solutions. So we'll test this point. We'll plug in 6 for x, 1 for y. We will simplify. And yes, it's a solution. We'll plug in the other ordered pair, 3 for x minus -2 equals 5. This is the first place where students will make a mistake. And let's show why that is the case. Let's put that ordered pair back up here, 3, -2, and we write x minus y equals 5. So we're going to substitute 3 in for the x value. And then we're going to write the negative, and then we're going to substitute the y value, and then we're going to write the equal and the 5. Those are things that aren't going to change. The only thing that's going to change is my x value and my y value. This negative is separate from the y. So that's why we have this. We have 3 minus negative 2, which we would simplify to 3 plus 2, which is 5 equals 5, and that's a true statement. So both are solutions to the ordered pair, or to the equation, sorry. So 3 comma negative 2, let's plug in 3 for x, negative 2 for y, equals 8. That's 6 minus 2 equals 8. That's 4, does not equal 8, so not a solution. That's a no. That's a no for me, dog. Then let's plug in negative 3, negative 2. So we have 2 times negative 3 plus negative 2 equals 8. That's negative 6 minus 2 equals 8. Negative 8 also does not equal 8. So that is a no also. So neither problem is a solution to the equation. 3 comma 1. Let's plug in 3 for x plus 3 times my y value equals 6. We're going to multiply before adding. And then we're going to add. We're going to simplify the side. We're not moving things anywhere. So that is yes, that is a solution. And then negative 3, 3. And x is negative 3 plus 3 times my y value. So negative 3 plus 9 equals 6. And yes, 6 equals 6. So both are solutions to the equation. The first ordered pair, 12 minus my y value, which is 6, equals 2 times my x value, which is 3. 6 equals 6, so that's a yes. 4 comma 4, we have 12 minus my y value equals 2 times my x value. 8 equals 8, and that's yes also. Let's write the first coordinate. We're going to test it. 5 times 3 minus 3 times 5 equals 0. That's 15 minus 15. 15 minus 15 is 0, so that's a yes. And we're going to test negative 3, negative 5. So 5 times negative 3 minus 3 times negative 5 equals 0. That's negative 15 plus 15 equals 0. And 0 still equals 0. So that is a yes also. 2 comma 1. 2 times my x value minus 4 times my y value. That's 4 minus 4. 0 equals 0. That's yes, that's a true statement. And 1 comma 1/2, I like fractions. 2 times my x value minus 4 times my y value equals 0. 2 minus 2 equals 0. 0 equals 0. And that's yes also. Let's check the solution or the coordinate. For 0, 3 times, so notice we are in A comma B. Since our two variables are A and B, A would be my first, so A is 4, minus 4 times my B value equal 12. 12 minus 0 equals 12. 12 equals 12. So yes. My next point is 0, 3. So this time A is 0, B is 3. So 3 times A minus 4 times 3 equals 12. 0 minus 12 equals 12. Negative 12 does not equal 12, so that is a no. M and N, so this is my M and this is my N. So 2 times 6 minus 3 times 2 equals 6. 12 minus 6. 6 equaling 6, so that's a yes. 9, 4. 2 times 9 minus 3 times 4 equals 6. That's 18 minus 12 equals 6. 6 equals 6. Yes, it does. So this is a solution. 4 comma 2, we're back to x and y, so 2 times my x value plus 5 times my y value equals 18. 8 plus 10, 18 equals 18. That's yes. 3 halves comma 3, so 2 times 3 halves plus 5 times 3 equals 18. That's 3 plus 15. 18 equals 18. That's also yes. Mn, so this is my m, this is my n. So 3, 1, we have 5 times my m value minus 4 times my n value equals 11. 15 minus 4 equals 11. 11 equals 11. Yes. 2 comma 1/4. 5 times 2 minus 4 times 1/4 equals 11. That's 10 minus 1. That's 9. Does not equal 11. Yep, that's correct. So that's a no. Ooh, this is good. So we still are x, y. So we're going to try the point 16 1/2. So 16 times 1/2 equals 8. 8 equals 8, yes. And we get -4, -2. I like this. So -4 times -2 equals 8. And yes, 8 equals 8. So that's yes also. Lots of practice problems. All right. So 1/4, 8. So we have 2 times my x value times my y value equals 4. 2 times 1/4 is 1/2. We're going to do this multiplication first, orders of operation, left to right. And then we're going to take half of 8, which is 4. So yes, that worked. And let's try -2, -1. That's 2 times my x value times my y value equals 4. 2 times -2 is -4. -4 times -1 equals 4. So that is a yes. So both of those were solutions. Oh, now we're squaring. Look at that. So 2, -1. You have 2 squared plus quantity 1 squared equals 5. How many of you wrote the quantity? Because if you didn't, you can't write this. That's totally different. This is squaring 1. We're not squaring 1, we're squaring y. And my y value is -1. This is not going to give you, this is the proper way. So notice the difference of answers. And we want to square -1, not 1. So this is 4 plus 1, because -1 times -1 is 1, and 5 equals 5. I got that without doing it. Well, you notated it incorrectly. So make sure that you are writing that correctly. We again have the coordinate 3, -2. So that's going to be 3 squared plus the quantity -2 squared equals 5. Look, you want to be able to write intelligently. You want to be able to write like you know what you're doing. And so teachers are going to be aware of whether you are writing and notating your work appropriately. So this is not a solution. This is 3, -1, so we're going to square minus -1 squared equal 10. This is another good one. You cannot combine these two negatives. That would be multiplication, and we have to do exponent first. So that's going to be 9 minus -1 squared, which is +1. So that negative goes there. That solution goes here. And you get 8 equals 10. So that is no. Now we have the point 1 comma -3. That's 1 squared minus the quantity of -3 squared equals 10. That is 1 minus 9. That also does not equal, so that is a no also. Ooh, all right, this is another good one. So 5 and 5, so 5 squared minus 2 times 5 squared. So we would not do the multiplication. We would do the exponents first. So we can do that. That's an exponent. 25 minus 2 times 25. And that's going to give us 25 minus 50, because we're going to do multiplication before subtraction. And this gives us negative 25 equals 15. No. So we know that this is not a solution. Let's try the point 4 comma 1. You are going to square your x minus 2 times your y value squared equals 15. That's 16 minus 2 times 1. And that is 16 minus 2 equals 15. And 16 minus 2 is 14, does not equal 15. So that's a no also. Both of those no. Okay. Wow. All right. We're going to really keep going here. So, whoops. 3 comma 2. We have 2 times my x value squared plus 3 times my y value squared equals 30. 2 times 9 plus 3 times 4 equals 30. 18 plus 12. And 18 plus 12 is 30. Does 30 equal 30? Yes. So that's a solution. We have the point negative 3, 2. So 2 times the quantity negative 3 squared plus 3 times the quantity 2 squared equals 30. 2 times 9 plus 3 times 4 equals 30. 18 plus 12. And 18 plus 12 equals 30. So yes, that is also a solution. So both coordinates are solutions. Solve 2x plus 3y equals 6 for y in terms of x. So we are looking to isolate for the variable. We want to get y by itself. So we're going to get rid of things being added and subtracted first. So we subtract 2x from both sides. We notice that we subtracted 2x. And then we are going to get rid of what's being multiplied by dividing. And we will divide. Now, personally, you can write this. This is not the best way to write it. I would have written y equals negative 2x plus 6 over 3, or I would have done negative 2/3 x plus 2. To me, that's a little bit more attractive when we're solving for y, because we want it in slope-intercept form. This is going to be the slope, and this is going to be the y-intercept. In this form, it's kind of hard. Some people think that that's the slope and that's the intercept. That would be incorrect. So you see how that might lead you to a wrong linear equation. But it's okay. So we're going to solve for y. We're going to subtract 3x first. We're going to write y equals negative 3x plus 6. And that's my answer. I'm always going to write my answer in standard form, variables before constants. I'm going to minus 2x. I have negative y equals negative 2x plus 5. Remember, I'm solving for y, which has a coefficient of 1. This has a coefficient of negative 1 at the moment. So I am going to divide by negative 1. And when I divide by negative 1, I have to divide each of the terms on the right side by negative 1. So we get y equals positive 2x minus 5. We're going to combine these two negative signs. We're going to combine these positive and negative. We're never going to write double signs. That can be simplified. You would never leave it as double signs. We don't write plus negative 5. Don't write 2x plus negative 5. Don't write 2x plus negative 5. No. Don't give me double signs. I don't know who taught you double signs. This is the only answer I want to see. So we're isolating for y. We're going to get rid of things being added and subtracted first. 2y equals negative 3x plus 7. Now we're going to divide by 2. So we're going to divide everything on the right side by 2. We get negative 3 halves x plus 7 halves. That's the best answer. You can leave it like that. You wouldn't turn it into a decimal. You wouldn't turn it into a mixed number. Nobody wants to see a mixed number for a slope. They want to see an improper fraction. There is nothing improper about an improper fraction. We're isolating for y. We're going to subtract x. We're left with 3y equals negative x plus 9, variables before constants. We're going to divide by 3. Y equals negative x over 3 plus 3. So this is y in terms of x. The other answer you could have given is y equals negative 1/3 x plus 3. So those are okay. We have to understand that negative x over 3 is the same as negative 1x over 3, which is the same as negative 1/3 x. The x is in the numerator. Notice where the x is. The x is in the numerator. The x is in the numerator. The x is in the numerator. Negative 1 is in the numerator. Negative 1 is in the numerator. Negative 1 is in the numerator. And 3 is in the denominator, denominator, denominator. So these two statements are equivalent. Those are the same values. Let's get rid of things being added and subtracted. You're left with 2y equals negative 4x. 2 is multiplying y, so the inverse of multiplying by 2 is dividing by 2. And we must simplify. You must always simplify. Must simplify. It baffles me on how many students don't simplify fractions. Minus 5x, subtract 5x. 4y equals negative 5x plus 10. We can't combine these because those are unlike terms. One is a variable, one is a constant. Those do not combine. We will divide by 4. We get y equals negative 5/4 x plus 5 halves. You must simplify. Simplifying 10/4 equals 5 halves is called simplifying. Turning 5 halves into 2 1/2 is not simplifying, that is converting. That's converting. We don't have to convert. So you notice that I didn't turn 5 halves into 2 1/2 because you don't have to convert, but you do have to simplify. So 10/4 cannot be, that needs to be simplified, so we must reduce that. But we don't have to turn it into a mixed number because that would just be converting the format. You have 3 formats. You have a fraction, a mixed number, and you have decimal. All are equivalent, all are acceptable. All right, so it says solve each equation if x and y are whole numbers. Okay, whole numbers. So first thing we're going to do is we're going to set it equal to y. So we get y equals negative 2x plus 4. And so y equals negative 2x plus 4. We're going to start plugging in for x values, and we're going to see what we get for y values. Or we'll write it as a... So I'm going to start at 0. And so if I plug in 0, what do I get for y? I get, I get y equals 0 plus 4. You get 4. So that's okay. That's a solution. I'm going to go to 1. Why did I choose 1? Because they have to be whole numbers. Whole numbers start with 0 and then go to positive infinity. But both my x and y need to be whole numbers. So when I plug in 1, we get y equals negative 2 times 1 plus 4. Y equals negative 2 plus 4. Y equals 2. So notice my x and y are whole numbers still. I'm going to plug in 2. y equals -2 times 2 plus 4, y equals -4 plus 4, y equals 0. 0 is still a whole number, so that is a solution. Let's go to the next whole number. For my x value 3, y equals -2 times 3 plus 4, y equals -6 plus 4, y equals -2. Not a whole number. So that is not a solution. So my solutions are 0, 4. Do they list them? The solutions, yes, so they did list them. You see the solutions are there, so I'm going to list my solutions. So my solutions are 0, 4, 1, 2, and 2, 0. Mr. Mack, why did I start with 0? Why didn't I start with -1? Well, because -1 isn't a whole number. So I'm always going to start with 0 in my x value, and I'm going to go and increase until my y value is not a whole number. Okay? So that's what we're doing here. First thing we do is we isolate for y. We write it in, technically it's slope-intercept form, but mx plus b, mx plus b, y equals mx plus b. So here's my equation that I'm going to plug in. Here's my x, here's my y. I'm going to plug in 0. I get 7. That's okay, that meets the standards. Y equals -3 times 1 plus 7. Y equals -3 plus 7. Y equals 4. 2. Y equals -3 times 2. 2 plus 7. Y equals -6 plus 7. Y equals 1. 3. Y equals -3 times 3 plus 7. Y equals -9 plus 7. Y equals -2. Not a solution. So 3 doesn't work. So we again have 3 answers. We have 0, 7, 1, 4, and 2, 1. Now, why are we doing this? This isn't really relevant. This is not a relevant skill to do. You're not going to do this ever when graphing solutions. I really don't know. Maybe it's the ability to read and understand problems. I don't know. I've always struggled with this exercise, but we do it. We do it because it's good practice, and who knows, maybe somewhere down the road somebody asks a question like this. Okay. And so there is my isolating for y. You notice that I chose to write it as a fraction instead of -x over 3 like this. I changed these two. Those are the same. Just because I'm going to plug in values. So x, y, here's 0. Let's plug in 0. And you get -1/3 times 0 plus 2, which is 0 plus 2, which is 2. That works. 1, y equals -1/3 times 1 plus 2. Y equals -1/3 plus 2. Y equals 1 2/3. Not a solution because it's not a whole number. So that didn't work. That doesn't necessarily mean that we're done. Oh, we're done. No, because it's 1 2/3. So we might get a value somewhere close to, let's check, 2 plus 2, that's going to give me a fraction because that's -2/3 plus 2. That gives me 1 1/3. Also, not a viable solution. Hold on. Does 3 work? 3, let's check 3. Y equals -1/3 times 3 plus 2. That gives me, -1 plus 2, which is 1. So that worked. That was a good one. Is 4 going to work? No. That'll give me a fraction. Is 5 going to work? No. That's going to give me a fraction. Is 6 going to work? Yes, it is. Do you notice that you need multiples of 3? So y equals negative 1/3 times 6 plus 2. And that's y equals negative 2 plus 2. Y equals 0. 0 is a viable answer. So that worked. So we again get 3 answers. We get 0, 2. That's not the best 2. That's a good 2. We get 1, we get 3, 1, 3, 1, and 6, 0. Those are our solutions. Minus x, 2y equals negative x plus 5, divide by 2, divide by 2, divide by 2. Y equals negative 1/2 x plus 5/2. We're going to keep it like that. Y equals negative 1/2 x plus 5/2. It's going to be interesting to see what works and what doesn't work. 0 is not going to work because we're going to be left with 5/2. Did you see that? You see how this starts working in the trick on how that's a no-go. Can't have a fractional answer. Is 1 going to work? Let's check it out. Let's see. Does 1 work? Times 1 plus 5/2 equals negative 1/2 plus 5/2, which equals 4/2, which equals 2. Yes, that worked. Oh, so do you think 2 is going to work? What do you think? No, 2 is not going to work because what's going to happen? Because we're going to get a whole number out of here. So that's going to be negative 1 plus 5/2, which will give you positive 3/2. That doesn't work. So even numbers aren't going to work. It's only going to be odd numbers that work. So we're going to try 3. 3 will work. 1/2 times 3 plus 5/2 gives you negative 3/2 plus 5/2, which is 2 over 2, which equals 1. That worked. We're not going to do 4. 4 we know is not going to work. Let's do 5. 5 will work. Negative 1/2 times 5 plus 5/2. Y equals negative 5/2 plus 5/2, which gives you 0. And we don't keep going because anything greater, let's say we do 7, we're going to get into negative, and that wouldn't be whole numbers. So we have 3 solutions. We have 1, 2. We have 3, 1. And we have 5, 0. Yeah, pretty cool. Solve for y. 3y equals negative 2x plus 8. Divide by 3. Y equals negative 2/3 x plus 8/3. Woo, can you think and figure out what's going to work? Negative 2/3 x plus 8/3. Is 0 going to work? Because 0 is just going to cancel out that first term, and you're going to just be left with the 8/3. So no, that doesn't work. Okay, does 1 work? Well, 1. All right, that might work, right? 1, because that leaves me with thirds, but is it enough to cancel out the thirds? So we get negative 2/3 plus 8/3, which is y equals 6/3, which equals 2. Yes, that worked. Nice. Will 2 work? Well, 2 is going to be 4/3, right? 2 gives me negative 2/3 times 2 gives me negative 4/3, plus the 8/3 is 4/3. That's not a multiple of 3, so that doesn't work. No. Well, 3 looks nice, right? No, 3 doesn't work. Do you know why 3 doesn't work? Because 3 is going to cancel and produce a whole number. And then you'll have a whole number plus the 8/3. So that's not going to work. Plus 8/3, meaning the 3's are going to cancel. You're left with negative 2 plus 8/3. So that's not going to work. How about 4? I think 4 is going to work. What do you think? I think 4 is going to work. I think 4 is going to work. Negative 2/3 times 4 plus 8/3, and you get negative 8/3 plus 8/3, which equals 0. So this time we only have 2 solutions. So our 2 solutions are going to be 1, 2 and 4, 0. Okay, so hopefully you're seeing these tricks to the trade and what's going to make it work, what's not going to make it work, what's going to keep us in the whole number range. So 0 should work. 0 gives you 9. 1 gives you 6. 2 gives you 3. 3 gives you 0, and we're done. So now we didn't even have to write any of the work down. We see how that's working, plugging in, getting values, and seeing how the increments are going. You notice that we diminish by 3 for every whole number. Minus 2x, minus 2x, 3y equals negative 2x plus 6. Divide by 3, divide by 3, divide by 3. Y equals negative 2/3 x plus 2. So let's think about what's going to work and what's not going to work. So 0 will work because we'll be left with 2. Will 1 work? No. 1 doesn't work. That's a no-go. Does 2 work? No. 2's not going to work. That's a no-go because that gives me a fraction. Will 3 work? Yes, 3 will work, and it'll give me 0. So I have 2 working solutions that adhere to the stipulations of whole numbers. Okay, solve for y. So we got to divide by x. Divide by x. Y equals 3 over x. This is interesting. So if I plug in 0, you get 3 over 0, which is no solution. Not 0, it's no solution. So that is not acceptable. If we plug in 1, we get 3. You plug in 2, you get 3/2. 2 doesn't work. Plug in 3. Ah, yes, 3 works. That's 1. Are we ever going to get 0? What if we go 4? That's 3/4. Not good. That's a fraction. And do you notice how as we increase, 4 is 3/4? Oh, well, let's use 6. Nope. That simplifies to 1/2. And what do we notice about those numbers? They keep getting smaller and smaller and smaller. So these never work. So we only have 2 solutions. We have 1, 3 and 3, 1 are our solutions for this. Oh, minus 1, get rid of the addition and subtraction first. And now we're going to divide by x, and we get y equals 6 over x. Y equals 6 over x. This is my x. Again, 0 does not work. 1 does. 1 provides us 6. 2, yes. 2 gives us 3. 3, yes. 3 gives us 2. Ooh, these are nice. 4, no, that gives us, 4 gives us 3/2. Let's do this. 6/4, which reduces to 3/2. That's a no. 5, no. 6, yes. 6 gives us 1. And do you know that you'll never get 0? You'll never get to 0. You'll get infinitely close. When we got smaller and smaller, you see we went from 3/4 to 1/2 to 1/4 to 1/8 to 1/16. We're going to keep getting closer and closer to 0, but we will never get 0. So the only way to get 0 is having 0 in the numerator, and we have a constant in the numerator of 6. So we did get a couple more solutions, and those solutions are 1, 6, 2, 3, 3, 2, and 6, 1. Those are my answers. Minus 2, xy equals 7. Divide by x, y equals 7 over x. These are going to be even more limited. X, y, 0 doesn't work. 1 gives you 7. 2 doesn't work. 3 doesn't work. 4 doesn't produce a whole number. 5, no. 6, no. Whoa. 6, no. 7, yes. 7 gives you 1. So these are all no, 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 yes. So you only have 2 solutions. You have 1, 7, and 7, 1. Don't know if you know why that's the case, but solve each equation of x and y. So here's a very challenging one. If we're going to solve for y, I'm going to factor out a y. Notice both of these terms. I can't combine them because they're not like terms. And I can't move the x over, because if I divide by x, I got to divide this by x and this by x. That just doesn't work. So both of them have a common factor of y. If I factor out, I get x plus 1 equals 3. You should know that by chapter 8. And now I'm going to divide by x plus 1, divide by x plus 1. We get y equals 3 over x plus 1. Really good, advanced. Are you able to work with this problem outside of any type of assistance? Meaning, did you notice the trick to this one? So if we plug in 0, we get 3 over 0 plus 1, which is 3 over 1, which equals 3. That's good. If we plug in 1, we get 3 halves. That's no go. 1 plus 1 is 2, 3 over 2. 2, that works. That gives me 3 over 2 plus 1, which is 3 over 3, which equals 1. Can we get to 0? If I plug in 3, that's 3/4. That's no. And we again are getting closer to 0. Can we ever get to 0? No. The only way you can get 0 as a fraction is 0 in the numerator. And our numerator will always be 3. It's never going to be affected. So we can't. So we only have 2 solutions here. We have 0, 3, and 2, 1. Oh, one more. So we again are going to factor out the y. We get x minus 2 equals 4. We're going to divide by x minus 2. We get y equals 4 over x minus 2. Y equals 4 over x minus 2. And we got x. We have my y values. 0 is going to produce negative 2. Ooh, I almost made a mistake. 4 over 0 minus 2, which is 4 over negative 2, which gives you negative 2. Not a whole number. 1. 1 gives us negative 4. That's a no-go. 2. 2 gives us 0. 4 over 0, which is no solution. Sorry, that equals no solution. That's no. 3, no. That's going to, oh, yes, 3 yes. 3 yes. 4 over 3 minus 2 is 4 over 1, which equals 4. So we got a solution finally. 4, nope. Oh, yes, sorry. Just do it, Mr. Max. Stop guessing. That's 2, that's okay. 5, probably not. 4 over 5 minus 2 is 3, 4/3, no. 6, yes. 4 over 6 minus 2 is 4 over 4, which equals 1, that works. Let me show a no-go, no. That's a yes, that's a yes, that's a no. And are we ever going to be able, this 1, can we get 0? No, because the numerator is never going to change. So there's no need for us to go past 6. So my solutions are going to be 3, 4, 4, 2, and 6, 1. Good? All right. I think that was the last one. And yeah, maybe that's not relatable in the sense that teachers will ask you that, but I will tell you that that's a good in a comprehension way of comprehending how to read directions, how to work, and this is what we call number sense. So these are really good number sense problems, understanding how plugging in a value is going to produce a certain type of value. Can you anticipate what it's going to, how it's going to affect the equation and work within your constraints, which is whole numbers. Good luck.